Hello and welcome to the QA Therapy podcast. Are you looking to improve your overall testing and quality practices? My name is Sergio Freire and I'm a solution architect and a testing advocate at Xray.
And my name is Cristiano Cunha, and I'm also a solution architect and test advocate. And we'll be your hosts and QA therapists throughout this series. In this podcast, we're going to tackle some of the most common testing and quality challenges that we all face in our teams. So if this sounds good to you, keep on listening. Systems in general, including software and hardware, usually have some input parameters that will affect the output produced by the system. The number of parameters and the possible value, their ranges, vary. It can be limited, huge but finite, or even infinite. This potentially leads up to a high number of scenarios to be tested, easily reaching the hundreds of thousands. In general, we could think that if we aim to test systems like this in depth, we will need to test them with all the possible combinations of values of these parameters. But does that even make sense? Are any of those scenarios redundant? Or, in other words, is there any manageable subset of scenarios that can be tested that can still help us find bugs? To assist us on this topic, we have a special guest with us, Ivan Filippov. But before welcoming him, let's just see, as usual, what is bringing you here. What are the symptoms that you are feeling? So ask yourself, do you have to test the same features in many different configurations or environments? Or do you feel overwhelmed with the number of test scenarios that you have to perform for a given feature or product? Or even, are you unsure about which combinations of input parameters to test, which ones are relevant for the purpose of finding faults? Do you feel you're leaving many different scenarios uncovered, or that you're not testing enough? Or finally, are you pressured by time and don't know exactly which scenarios to test for a given feature?
All these are symptoms that maybe there's no clear understanding about which scenarios needs to be tested or what combinations of parameters or environment may be more valuable to expose faults related with those parameters or those environments. Maybe there's an existing underlying understanding that we need to test everything, which ultimately could lead to frustration. So let's dive a bit into this topic. And as Cristiano mentioned, we have here with us Ivan Filippov, our expert QA therapist, to assist us on diagnosis and prescription on these symptoms related to testing complex scenarios. Ivan has worked for several years with teams helping out building efficient test models that can be used to expose important defects. He is now part of the Xray family, where he continues to help testers make better testing with less testing. Sounds contradictory? Not exactly, as we'll see. Welcome, Ivan. Are you comfortable on our QA therapy couch?
Yes, hi.
It's
Thanks for
our
having me.
pleasure. So, to get the show started, let me start with the initial question. Uh, what are the typical challenges that critical apps and sites face nowadays? Is variation one of them?
Definitely. The number of dependencies, both internal and external, and the number of possible ways a user could interact with the system, I'd say are two key challenges to consider when developing and testing critical applications.
So we are talking about variations, but where does these variations come from? Are we just talking about input parameters, or are there any other variations that we should take into consideration?
Um, Input parameters are a large part of it, and if we look at, for example, mortgage or property insurance applications, there are good examples of that with multiple pages of details collected from the user. However, the system outputs also often depend on different environments or contexts. We can think about device configurations, operating systems, time zones, user types, and things like that. And if we just for an example purpose, think about a relatively small set of tests based on just the input variation, say 20, and have the need to run it for each combination of 3 user types and 4 devices, we end up with a seat size of 240, right? So you can see how even small factors complicate the variation challenge once all the iterations, all the multiplications are considered. And of course, both input and environmental types of variation ideas should be accounted for in testing.
So I think you kind of already touched a bit of it, but what does variation will ultimately have as a consequence in terms of testing? Can you give an example?
Yeah, absolutely. Even in the simplified one I just mentioned, the count grew to a couple hundred tests very quickly, right? If we're thinking about real world systems with at least medium complexity, that same calculation and the same logic could easily reach thousands or millions. And at that point, testing everything as a strategy becomes not just costly or time consuming, but simply impossible.
Exactly.
Yeah, and all of this has a purpose, right? We need to enhance the number of tests that we are doing, but we need to cover most of it. So, what about faults? What do we know about faults? Are there any relevant studies that can tell us a little bit more about it
Yeah, for
from your point of
example,
view, of course?
yeah, absolutely. For example, such studies as estimating T-wave fault profile evolution during testing and practical combinatorial testing, presented by the National Institute of Standards and Technology in 2017 and 2010, respectively. Their primary message is that the vast majority of production defects, on average about 84 across several industries that the research was done on, happen due to a problem with either one parameter, also called single value fault, or a combination of values from two parameters, aka two-way interaction fault. And when the researchers started looking beyond that, defects related to the interaction of more than two parameters are increasingly more rare. It doesn't mean they won't happen or that they won't be critical, but in general, finding them would require many more tests to be performed, which often just stops making sense from the time and cost perspective.
That's quite interesting. In fact, we think that we have to test all the possible combinations of parameters or test all of that even in different contexts. But then, let's say what comes from the field tell us that most faults come from this one or two level or two way of interactions. That's quite interesting. Another question is was once in a while I hear about testing randomly, and well, is random testing a valid approach for addressing this sort of combinations where sometimes we test a feature with certain values and another time with another values? If not, why?
Right, yeah, that's a good question. As an approach, I would say it could be considered valid, maybe, but definitely insufficient. While random testing can do a decent job finding single value faults, lack of systematic approach leaves it very vulnerable to two-way ones, right? Because you could cover some interactions simply because multiple parameters participate in a test, but you wouldn't have traceability of the overall picture, and you wouldn't easily understand what are the coverage gaps remaining. And that means you risk encountering a significant part of those 84% in your production experience. And to maybe provide a little bit more context about the impact, there are plenty of public real world examples when two-way interaction defects did serious damage to the company. And some of the more recent ones include Tesla, when the combination of cheap power
Hmm.
mode and action on the road resulted in false warnings or emergency brake events. Uber, when the device type, or I guess the device target, and login status together caused incorrect notification behavior. And maybe the last example, Slack, when the type of recipient and the invite content resulted in the flood of unsolicited messages. And so, given all these shortcomings of random approaches, from my perspective, combinatorial testing emerged as a more thorough alternative.
Yeah. At least we are cutting out the luck, because there are a lot of lucky testers out there that think that find things by, well, they sometimes they call it experience, other times it's just pure luck. But if you, like you said, if you don't have a systematic approach, you will probably have luck sometimes, but we cannot guarantee that you are covering everything.
Right.
But coming back to this approach, what is now coming more to the technical side of things? So what is pairwise and T-wise testing all about? Can you just elaborate a little bit about this?
Sure. As defined by the International Software Testing Qualifications Board, it is a black box technique in which test cases are designed to exercise specific combinations of values across relevant parameters. And such application of mathematical methods in software testing is aimed at finding a good balance between efficiency and defect prevention that we just talked about. And the approach can be applied to both input and environmental types of variation ideas. The core function, I would say, of combinatorial algorithms is identifying the smallest mathematically possible set of iterations to satisfy the interaction level condition.
And a bit related to that, Ivan, are there any ways of testing more or less thoroughly with this approach in order to cover more or less potential interaction faults?
Yes,
Are there some ways of, let's say, adjusting according with the needs?
right. Yeah, that's an important point. And there is quite a bit of flexibility that as a tester or as a designer you have with this approach. And the condition I mentioned is that lever that allows you to control the thoroughness. It is defined by a numeric value, which reflects how many parameters participate in the interaction that needs to be covered. So, for example, the condition of 2 requires each pair of values to be included in the generated set. 3 means each triplet, and so on. And that's pretty much why this testing technique is often referred to as T-way combinatorial testing, where T is that numeric condition. However, this is a bit dependent on the situation. You may prefer a more flexible manual intervention after the initial set of tests is created. So, for example, let's say there are only a few business requirements that specify the interaction between 4 parameters. In that case, pushing the lever all the way to t equals 4 may be excessive, and you may choose to stay at t equals 3, maybe even t equals 2, somewhere in between, and then just account for those super specific, super thorough requirements by adding them to the table afterwards.
So how can we use this? So can you tell us a little bit more about how a test case design process using these techniques can work? Well, at a very high level, of course.
Sure, good question. It starts with the requirement analysis as any other testing process, but instead of writing individual tests per acceptance criteria, we take a step back and build a model for the scope we define. And such a test model contains the list of relevant variation ideas and corresponding values that we discussed at the beginning of this. And then the next step is to ensure that all generated tests, when we get to that point, will be valid by applying all the business and system rules that affect parameter interactions within the model scope. And that point is very important because in theory you could put a lot of different things in the same model, but it's important to decide what exactly are you testing at that moment for that particular project. And then once those components are all in place, we actually generate the tests using the combinatorial methods I've described. And from the format or I guess deliverable standpoint, at that moment, the result is just the data table where each row represents a test case with a unique combination of parameter values. Then depending on your execution setup, you may also need to create one or multiple scripts with steps and expected results to guide the execution.
Ivan, we have been talking about parameters and, well, the also connected to that, there's like the values for those parameters, the values that those parameters can take. But starting with parameters, are all the parameters really relevant for the purpose of building out that model that we are talking about? And if not, can you give an example? Because I remember sometimes you have like forms with bunch of information. Is all that information really relevant for the purpose of building out a model that we want to use for the basis of our tests?
Yeah, that is probably the key decision or the key knowledge that a tester should possess when they start learning about this technique. And the impact on the outcome is the most critical factor for the inclusion decision.
Mm-hmm.
If we consider an auto insurance policy application and the outcome of quote is generated correctly, then to a point about all the different fields, the demographic data like name or suffix or exact address are unlikely to be considered in the calculation.
Oh,
And
that's
so
a good point.
we don't need them as the model parameters, again, given our scope. And then some application factors, if we think about a slightly different category, may have a very small weight in the rating engine. Like we're talking 0.00001. And so again, including those probably won't hurt you, but won't help you that much either if we're talking about the riskiest factors, the riskiest parameters that would potentially cause the defect. And then we've been talking mostly, I guess, from the functional testing standpoint. If we switch for a moment to the integration one, and let's say we're trying to build a model for the testing between policy center and a billing center, then individual car details, make, model, year, and things like that may not matter anymore as much as the overall premium. And so in that model, we can either exclude them from or abstract them, simplify them to maybe just one parameter characterizing that car.
Okay, that seems quite, let's say, understandable, and it makes totally sense. Some fields are more informative and they don't really affect the calculations or the outcomes as you are mentioning.
Exactly.
Yeah. And you can have the best algorithm possible to choose them from, but if you are not choosing the right parameters, you will not have the right results. But looking at the value spaces for the input parameters, sometimes we have like infinite values for them or extremely high possible values for those parameters. So what can this technique help us with that?
Right. So
Well, we need them to. You know that most of the teams will say, well, we need to test everything.
right. Yep. So the answer depends a little bit on the algorithm that you are using or just the overall method of generation that you are using. And I guess talking about possibilities, such parameters or such value spaces can be handled either via the equivalence class and boundary testing techniques or via the exclusion from the combinatorial setting, which is not the same as the exclusion from the model, or both. And so the first method is probably more common, so I'll talk a little bit about that first. It involves breaking the value space into groups based on the business and system rule thresholds. In some cases, production selection metrics can also be considered. So, for example, again, going back to the insurance space, if you know that 90% of your customers only pick that particular option for that particular coverage, that could drive your decision about what to prioritize in terms of the values, even if there are 20 options for that coverage. And then once you do that grouping, each class becomes an input to the model rather than each individual value. And then, assuming the grouping is done right, the coverage confidence is still preserved with this approach, as the behavior within the group is similar enough, again, based on the outcome, that we expect the same risk profile. So overall, this method, for those maybe a little bit more familiar, is similar to clustering from the kind of traditional data analysis. And then the exclusion method basically means appending the value list in question as a column to the combinatorially created set, so that it doesn't impact the count nearly as much because we're not worried about interactions for it, but we still account for that value list because all the necessary values will be included in the tests as they are present in the row.
And Ivan, let's say whenever we have all these parameters, in fact, we all know that not all combination of parameters makes sense, right? Are we possibly talking just about impossible combinations or combinations that be non-representative or significant or both? I mean, there are combinations here that probably doesn't make sense to include.
Well, both types could be addressed when setting the rules on that step 2. While impossible combinations must be removed, right, so that we ensure the accurate execution coverage, the non-representative ones are a little more tricky and probably again a judgment call, since we know they could cause defects even if they are rare. So my recommendation would be limiting their occurrence without complete removal from the model, if that is possible. But I guess to flip your question a little bit, alongside exclusion, for any of those reasons, we should also consider prioritization, right? Because based on the definition, the key driver behind the generation is math, but the statistical side of the technique would not automatically account for the subject matter expertise, for the business domain knowledge, right? And it would treat each valid combination as equally meaningful, which is rarely true. So it is important to have the ability to affect the order of the tests, to affect the exact combination in some of the tests, especially if we're talking early on in the test suite, so that you can get your critical risk coverage executed as early as possible in your testing process cycle.
So what are the challenges around this combinatorial testing?
Oh yeah, that's a good point. Even though it is a very useful technique, there are obviously some shortcomings. And let's say the first one is that it often makes the test oracle challenge actually harder, at least in the short term, because as you unleash the algorithm on the combinations, many of the scenarios come back without being explicitly specified in the requirements. And so it can be difficult, even for the subject matter experts, to look at them and answer how was the scenario supposed to behave. If we have this particular combination of factors in the application, what was supposed to happen, right? And so that's the bad news. The good news is that asking those questions typically leads to eliminating requirement ambiguities a lot sooner in the development process, which improves the overall quality because you don't go at the last stage back to the first stage and start asking, okay, how did we miss some of these um, conditionals or anything else that would trigger the actually expected result. And then other common challenges include mindset shift, model scope, as we briefly talked about, and defect triage. So for the first one, it's just that thinking about a system or an application from the perspective of parameters, values, and their interactions is significantly different from traditional testing techniques. And therefore, combinatorial testing has a fairly steep learning curve, but the investment pays off typically in the medium term with the improvements to both efficiency and quality. And then for the second challenge, the model scope, not all models are valuable. And as we again briefly touched upon, not all features have the same importance. Not all aspects of a feature have the same levels of risk. Even with the theoretical understanding of combinatorial methods, this testing approach requires significant collaboration between testers, developers, and business stakeholders to determine the right level of detail and priorities for each generated test case. And of course, such collaboration ideally should happen regardless, but its importance is increased in combinatorial or broader in model-based testing. And then for the last challenge, it may be a little more hidden, but in the traditional manual approach, there is a clear focus item for each test, right? Typically, there's just one change, one value that we kind of wrap the test case around. So there is little doubt about what could fail in each execution run. It's usually right in the test case name. In the combinatorial approach, with most of the values changing from test to test, it can be hard to pinpoint the defect trigger, or maybe it was just an invalid input. And so that depends a little bit on how the error handling is set up, but overall, analysis techniques at the test suite level, rather than a test case one, can still help address this with reasonable time investment.
Ivan, what we have been talking here about this technique, and one thing that comes to my mind is more, let's say, the role of the tester. What is the role of the tester whenever using this technique? Uh, where where do you think the tester can provide the most value at?
Right, so the role becomes, I would say, similar to an investigator in a way, because it involves collecting information from the requirements and scope and then asking questions, I guess, first and foremost, about the rules, the outcomes, value spaces, all those things we've talked about, and then collaborating with SMEs on clarifying any ambiguous aspects. Of course, there is still the kind of hands-on application side where the tester would be doing any adjustments to the model and to the test suite, and that takes critical thinking because there are obviously multiple options for parameter and value inclusion, but that kind of investigator being the glue between different teams and making sure that there is an alignment on all the different aspects of the testing scope, I would say becomes the key.
Good point.
Yeah. And well, we have been talking about this technique for a while now, and it seems fairly useful. But like you said, the learning curve is a little bit steep, and well, it seems a little bit trickier for someone that has never used this technique. So, do you think that if we have a tool that already has embedded this technique, it will help its usage, or not?
I would say yes in most cases. If we look at traditional manual test design approach, and I guess not super specific to combinatorial testing, it often leads to the problems like redundancy due to inconsistent formatting or spelling errors or anything of the like, and then lack of specificity because oftentimes tests explicitly mention only some values and then the others are left a little bit more to their imagination. Maybe they're left as default, maybe they should be picked as any valid value just based on tester preference, but it leaves a lot of guessroom. And while doing combinatorial testing manually is possible for smaller scopes, the speed and completeness benefits of the algorithmic generation, especially for complex systems, are hard to deny. And I think that is especially true in the follow-up releases and from the maintenance aspect point of view, where a tester must figure out the impact on the regression suite. Because the first creation, that's one challenge, but then you need to understand which tests are still valid when the new requirements come in, which need to be updated and how, which need to be completely replaced or maybe removed. And typically, when only the manual approach is being followed, we see regression suites at clients just infinitely grow. Even if they started with a good optimized set of tests, then by the next release, they just pile on top of it. And in a couple of years, there are still thousands that need to be dealt with. Right? So that's where the tooling and the algorithmic side could really help out. And also, as we talked a little bit about the steps involved, if scripting is something that you're interested in and you need for your execution, then some tools have features to accelerate that step as well.
If, even on the algorithm itself, if we would try to generate by ourselves the combination of pairs or triplets by hand, probably it would be really hard. We take like a ton of time, and then in the end, we probably would miss some of those combinations.
Yeah,
So
definitely. Especially at higher levels of T, the
yeah.
manual effort really becomes quite troublesome.
And to take this, let's say, this tool topic a bit further, are there any open source tools that can help users? What are their limitations and like other alternatives that may be around?
There are quite a few. For example, picked from Microsoft, ACTS from NIST, and all pairs from Satisfies come up relatively frequently in the conversations. And the primary advantage, if we're talking about kind of comparing tools rather than comparing algorithms versus manual,
Mm-hmm.
is the strength of core functions around data table generation, especially when it comes to rule handling. But the limitation aspect of it, they're often a little harder to use, sometimes requiring, well, let's say, minimal coding expertise. And then they're also often behind on broader SDLC functions like scripting or seamless integrations with other tools in your toolchain. And then, of course, as any open source software, they typically lack dedicated support and client specific customizations. So their way of addressing the learning curve is probably suboptimal. And then on the other hand, if we look at commercial tools, they typically try to address those last two weaknesses while trying not to fall too far behind in the core algorithm capabilities. And that depends a little bit on how specialized the tool is.
Thank you, Ivan, and it was really a pleasure to have you here with us on our QA Therapy podcast. I hope you enjoy.
Yeah, thank
Absolutely.
you, Ivan.
Thank you for inviting me.
Before ending our episode, it's time for some vitamins. We know that in general they are good for our health. In this case, we'll be talking about vitamin X, where X stands for X-ray. The new Xray Enterprise comes with Test Case Designer, which is a comprehensive modeling tool where it's possible to define parameters and values, to enforce system under test rules, to generate optimized data sets using two-way or T-way settings up to a certain level within a few minutes. With Test Case Designer, you can have a manageable set of test scenarios to perform and make sure that most combinations of values are covered early on in the test suite so that most risk is addressed up front. Test Case Designer doesn't replace Xray built-in capabilities for parameterized tests and datasets. It's a more evolved approach. Both can be used in a given project.
And we are reaching the end of our episode. And as we have seen, combinatorial testing provides an efficient approach for supporting the generation of test scenarios involving multiple inputs parameters or multiple environments. Even though it's not a silver bullet, it's nevertheless a very useful technique that can dramatically reduce the number of scenarios to test, while at the same time ensure that relevant scenarios, or in other words, combination of parameters, are covered. So see you in our next therapy session. Happy testing!
Happy testing!